My name is Dr. W.A. Yahya. I'll be demonstrating experiment 17 titled Variation of Potential Difference of a Cell and Measurement of Internal Resistance of a Cell. The experiment has two objectives, which are to measure the internal resistance of the cell, and the second objective is to measure the electromotive force of the cell. So to carry out the experiment, the experiment is divided into two parts. So this is the circuit diagram for the first part of the experiment, and this is the circuit diagram for the second part of the experiment. So the experiment, you need a voltmeter. So this is the voltmeter. You need a cell, a dry cell, a 1.5 volt dry cell, D. You need the switch S. So this is the switch S. You need the rheostat R. This is the rheostat R, as well as an ammeter A. So this is the ammeter A. Before you connect the apparatus together, it is essential to measure the voltage, the potential difference of the battery before you begin with the experiment. And that is done using the voltmeter. So you take the positive terminal of the battery, you connect it to the positive terminal of the voltmeter, and the negative terminal connected to the negative terminal of the voltmeter. So you can see the reading gives approximately 1.5 volts, so about 1.49 volts. So it's good enough for us to use in the experiment. So now to join the circuit, the apparatus together, you connect the positive terminal of the cell with the positive terminal of the voltmeter to the switch. So the positive terminal of the voltmeter with the switch and connected to the positive terminal of the battery. Oh. Okay. Then the switch, the other terminal of the switch will be connected to the rheostat. So this is the other terminal of the switch will be connected to the rheostat. So you ensure that you do not close the switch at this moment. Then the other terminal of the rheostat will be connected to the positive terminal of the ammeter. Okay. Then you connect this terminal of the ammeter to the negative terminal of the voltmeter as well as the negative terminal of the cell. So you have the negative terminal of the ammeter, the negative terminal of the voltmeter, both of them will be connected to the negative terminal of the cell. Okay. Now, so what you now do is you can close the switch. If you close the switch and you start from one end of the rheostat, so we're going to take two readings of the voltmeter, the PD reading in voltage, in volts, as well as the current in ampere. So we'll take about 5 readings. So let's start from a small resistance introduced into the circuit. We'll take our reading, a small resistance. So the reading on the voltmeter gives me, let's say V1. I have my reading, so let me call it V1. Then you take the reading on the ammeter. So be a small reading on the ammeter. I'll call that I1. Then you increase the resistance. So we need about 5 readings. So we need to move like 5 times between one end of the rheostat to the second end of the rheostat. So now the voltage reading has reduced. So let me call it V2. And the currents are slightly increased. So I call it I2. So you do that for the third point, the fourth point, as well as the fifth point. So as you move from one end of the rheostat to another, the value of the potential difference will start decreasing. So V1 will be greater than V2, V2 will be greater than V3, and so on and so forth. So we have V5. And the currents will start increasing. You can see if you look at the last reading here, okay, I've got the voltmeter reading giving around 0.7 volts, and the ammeter reading giving around 0.3 amps. So the current value will increase, while the voltage values, the potential difference, will reduce. So after taking these readings, so determine the internal resistance and the electromotive force. We'll recall that the EMF of a cell is the sum of the potential difference plus IR, where I is the current flowing in the circuit and R is the internal resistance. So what we need to do is to rearrange this so that V, which is the voltage potential difference, will be plotted on the vertical axis. So we will have V equals E minus IR. Okay, so if you compare this with the equation of a straight line, or let me rewrite it as minus IR plus E. So if you compare this with the equation of a straight line, Y equals mx plus C. So you find out Y, which is the vertical axis, will be V. So we've got a graph that we plotted will be V against I. So V, the potential difference V, as well as the current I. So V will be on the vertical axis, while I will be on the horizontal axis. And the slope of the graph, if you look at, I told you that V1 is greater than V2, V2 greater than V3, and so on. And I1 is less than I2, less than I3, and so on. So the graph will be, will have a negative slope, because as one increases, the other decreases. So if you calculate your slope, you get a negative value of your slope, and the slope in this case will be minus R. So if you get a negative slope, so your internal resistance will be negative of that value, negative of the slope. So M is the slope. Now, what about C? C is the intercept on the vertical axis, that is on the V axis. That is the point at which the current is 0. Okay? So this C will give you the intercept, which is the electromotive. So the value you measure here at this point will give you the electromotive force of the cell. So this is the first part of the experiment. So you're welcome to the second part of the experiment 17. And in the second part, we're going to make a little change to the circuit diagram in the first part. And the change is we're going to introduce an accumulator C. So we're going to use this as our source of accumulator. So this accumulator, the voltage to be supplied is 2 volts. 2 volts. So we're going to get 2 volts from this power supply, 2 volt direct current. So what we're going to do is between the switch and the rheostat, so we connect the accumulator. So we connect the positive terminal to ensure that the positive terminal goes to the positive terminal of this accumulator, goes to the positive terminal of the dry cell. So I'm going to place the accumulator between the rheostat and the switch. Then the rheostat will be connected to the negative terminal. So the switch to the positive terminal. So this is the positive terminal. And the rheostat to the negative terminal. Now, if we close this switch like this, the ammeter is going to read to the other part to deflect to the negative part. And since this ammeter is not a center zero galvanometer, it's not a center zero ammeter, so we're going to swap the terminal. So we will not, instead of connecting this to the positive terminal, so we'll not change it to the negative terminal, we'll not change it to the positive terminal. So we're just going to make 2 changes. Okay, so if I close the switch now, so I have a reading now, but I'll have a small reading of this ICs. I'm going to put minus. Why? Because I've swapped the terminal of the ammeter. It should have moved to the negative side. So I'll repeat the experiment the way we repeated for the first part of the experiment. So we need 5 readings between these 2 sides, between the ends of the rheostat. So this is first reading. Second reading, you take the voltmeter reading, you record it as V7, the current reading as I7, but you put a negative sign, as I explained earlier. So you take your third reading, the fourth reading, the fifth reading. So if you notice your voltmeter at this point, the voltage increases as I increase the resistance in the rheostat. It increases, and the current also increases in value. But of course, you have to introduce a negative sign. So at the end of the day, you are going to plot the voltage against current, and we have some negative values for the current. So we have, this is the positive side of the current, and this is the negative side of the current. So we'll have something like, in the first part of the experiment, we had this type of graph. So the second part, I told you the V6 is less than, so V7 is greater than V6, V8. So the voltage increases here, while the current also increases in negative, negative value of the current. So this is the diagram. This is the figure that we're going to work with in the second part of the experiment. So before you start taking readings for the second part of the experiment, so you should note that this V1 to V5 are the potential difference values obtained in the first part of the experiment. So you will continue with that. So the first reading you take in the second part of the experiment will be V6 and I6. So you just continue with the table. So this V1 to V5 are what the values are obtained in the first part of the experiment. So you did what we did earlier. So you calculate the slope and the intercept. So the slope will give you the internal resistance, and the intercept will give you the value of the electromotive force, the EMF. So the two, if you recall, at the beginning of the experiment, I said we have those 2 objectives. So the first objective is to determine the internal resistance of the cell, which is small letter r. So this is obtained from the slope. And the second objective is to determine the EMF, the electromotive force of the cell E. And this is the intercept of the graph. So there are questions for you to attempt in the manual. Okay, so please read through the manual. So there are questions for you to attempt. So you plot the necessary graph, calculate the slope, calculate the intercept. From the slope and intercept, obtain the potential difference, the internal resistance R, as well as the electromotive force of this cell, which is the second case. So this is the end of the second part of the experiment. Thank you.